The creation of the Earth, a cosmic journey. The Earth, our home, is a planet teeming with life, a dynamic blue-green sphere orbiting a star in the vastness of space. The story of Earth's creation spans billions of years and involves processes as old as the universe itself. It is a tale of cosmic evolution, beginning with the birth of the universe, the formation of the solar system, and finally, the gradual shaping of Earth into the planet we know today. To understand the creation of Earth, we must embark on a journey through the cosmos, tracing back to the origins of the universe itself. The Big Bang and the birth of the universe. The creation of the Earth cannot be discussed without mentioning the Big Bang, the event that marks the birth of the universe. According to current cosmological theories, the universe began approximately 13.8 billion years ago as a singularity, a point of infinite density and temperature. This singularity rapidly expanded in an event known as the Big Bang, leading to the formation of space, time, and matter. As the universe expanded and cooled, elementary particles such as protons, neutrons, and electrons formed. These particles eventually combined to form hydrogen and helium, the lightest and most abundant elements in the universe. For millions of years, the universe was a hot, dense plasma, but as it cooled, gravitational forces began pulling matter together, forming the first stars and galaxies. These early stars were crucial in the formation of the heavier elements necessary for the creation of planets like Earth. Within the cores of stars, nuclear fusion processes combined hydrogen and helium to create elements such as carbon, oxygen, and iron, ingredients fundamental to life and to planetary formation. The formation of the solar system. About 4.6 billion years ago, within a galaxy that would become the Milky Way, a vast cloud of gas and dust, known as a solar nebula, began to collapse under the force of gravity. The collapse may have been triggered by the shock wave of a nearby supernova, a massive star that exploded, sending energy and material across space. As the nebula collapsed, it began to spin and flatten into a disk, with most of the material concentrated in the center. This central mass would eventually ignite to form our sun. Around the young sun, smaller clumps of gas and dust began to coalesce, forming planetesimals, small, solid objects that would later merge to form planets. In the inner regions of the solar system, where temperatures were higher, rocky materials like silicates and metals began to dominate. In the cooler outer regions, ices and gases prevailed, giving rise to the gas giants like Jupiter and Saturn. Over time, these planetesimals collided and merged, growing larger through a process known as accretion. One of these planetesimals, composed primarily of rock and metal, would eventually become the Earth, the formation of Earth. From planetesimal to planet. The early Earth, formed about 4.5 billion years ago, was a vastly different place from the planet we inhabit today. It was a hot, molten sphere, constantly bombarded by asteroids and other debris left over from the formation of the solar system. These violent collisions added mass to the young Earth, but also generated immense heat. As a result, the planet remained molten for hundreds of millions of years. During this period, the process of planetary differentiation occurred. Heavier elements like iron and nickel sank towards the center of the Earth, forming its dense core. Lighter elements, such as silicon and oxygen, rose to form the Earth's mantle and crust. This differentiation led to the layered structure of the Earth, which we still see today, with a solid inner core, a liquid outer core, a viscous mantle, and a thin, brittle crust. Around the same time, a colossal impact occurred that would forever change the course of Earth's development. A Mars-sized body, often referred to as Theia, collided with the early Earth. The impact was so violent that it ejected a huge amount of debris into space. Over time, this debris coalesced to form the Moon, which continues to orbit the Earth to this day. The Moon has played a crucial role in stabilizing Earth's axial tilt, which in turn has helped regulate the planet's climate. The cooling of the Earth and the emergence of water. As the Earth continued to cool, a solid crust formed on its surface, and volcanic activity began to release gases trapped within the planet's interior. These gases, primarily water vapor, carbon dioxide, and nitrogen, contributed to the formation of Earth's early atmosphere. The early atmosphere was very different from the one we breathe today, containing little to no oxygen and being dominated by volcanic gases. One of the most critical moments in Earth's history was the appearance of liquid water. While some water may have been present in the materials that formed the Earth, a significant portion,